Hello and welcome to the 8th day of our polar equations unit. And today we're going to learn about operations on complex numbers in polar form. Now before we start up, we have to think about things that we haven't thought about in a while. Some rules with sines and cosines. Now if we take the cosine of negative theta, that's going to be the same thing as cosine of theta. And the sine of negative theta is the same thing as negative sine theta. And these two are the formulas for the expansion of cosine and sine of a plus b. Notice how cosine is cosine, cosine minus sine, sine, and sine is cosine, cosine, cosine a, sine a cosine b plus cosine a sine b. And then the last one, hopefully everybody remembers, sine squared plus cosine squared equals 1, the Pythagorean identity. All right. Now what we're going to do is we're going to find the product of two polars, polars and complex. So we want z1 times z2. So what that is 3 CIS 24 times 7 CIS 57. Now we're going to expand this. I'm moving to the left because it takes up a little bit of room here. 3 cosine 24 plus I sine of 24 times 7 cosine 57 plus I sine of 57. Now from here we could distribute over the parentheses, but it looks like this 3 and 7 we can just multiply right away to get them out of it. So we could multiply 21, and so we'll have cosine 24 plus I sine 24, and cosine 57 plus I sine of 57. So now if we FOIL, first outsides, insides, last. Well, we'll still keep this 21 on the outside, and we'll have cosine 24, cosine 57. The outsides will be I times cosine 24 sine 57. That's a 57. And the insides are going to be I sine 24 cosine 57. And then our lasts are going to be I times I, which is I squared, sine 24 sine 57. Whew. It's a lot to write. All right, now let's see what we can simplify. Let's put these sines together with these cosines, and I squared will turn this from a positive to a negative. So I'll have cosine of 24 cosine of 57 minus sine 24 sine 57. And then I'll just write the other two out as is. Actually, I can factor out an I on both of these. If I factor out an I on both of these, it would be cosine 24 sine 57 plus sine 24 cosine 57. All right, now I need another set of parentheses for that one. And now we look at this formula. Cosine 24 cosine 57 minus sine 24 sine 57. Hopefully that looks like that to you. So we can find our a and our b and combine them as the cosine of a plus b. So when we come down here, this is my a, that's my b. So we can combine all of this into being the cosine of 24 plus 57. And then this whole mess, cosine A sine B plus sine A cosine B, that looks a lot like this formula. So that would be the sine of A plus B. All right, so now this will be 21 times cosine of, what's that, 81 plus I sine of 81. And now we have our CIS. So this would be 21 CIS 81. Now that's a lot of work. So let's see if we can look back at the original problem and see how we can get 21 CIS 81. So if we just look at this, how can this be 21 CIS 81? Well, we can get the 21 by just multiplying the 3 and the 4. We can get the 81 by just adding 24 plus 57. So the product of Z1 times Z2 is just multiplying the modulus and adding the argument. So this is the formula that we use. R1 times R2, CIS, theta 1 plus theta 2. All right, so now if we want to do this the short way, Z1 times Z2 is just going to be 30 CIS. Now I got to check my math. I think this will be 166. Hopefully I did that right. And that's it. We're done. As long as you know a shortcut, we don't have to go through the long method. Now let's find the reciprocal. Now the reciprocal is 1 over. So what we're looking for is 1 over z. So we'll start this by 1 over 5 CIS 38, which is 1 over 5 cosine 38 plus 5 I sine of 38. Now what we're going to want to do here is multiply by the conjugate. So we're going to multiply by 5 cosine 38 minus 5I sine of 38. And let's see what our answer becomes. Our numerator is easy. 1 times that is just the numerator, 5 cosine 38 minus 5I sine of 38. Now, my first 5 cosine 38 times 5 cosine 38 is going to be 25 cosine squared 38. My insides are going to be 25I sine 38 cosine 38, but then my outsides are going to be negative 25 cosine 38 sine 38. So those two are going to cancel out, and that's why we multiply by the conjugate, so our insides and outsides cancel out. So now we just have to multiply the last. 5I sine 38 times negative 5I sine 38 is going to be negative 25 I squared sine squared 38. So I'll just write my numerator the same. And let's see what we can do with this denominator. This I squared can turn into a plus, and then I can factor the 25 out. So if I factor the 25 out, I'll have cosine squared 38. This I squared will turn this to a plus. And now I have cosine squared 38 plus sine squared 38. Hopefully everybody knows cosine squared plus sine squared of any number, as long as these two are the same, is going to equal 1. So, so this denominator just becomes 25. Now let's look and see if there's anything we can do out of the numerator. Let's factor out a 5. So that's 5 cosine 38 minus I sine 38. And like I said, this denominator is just going to be 25. Now this is great. We can simplify this, but it would be nice if this was in the form cosine I sine. And cosine I sine has a plus here. So what we can do is we can put it in that form by doing just a little trick. So first let's divide this out. So 5 divided by 25 would just be a 5 in the denominator. Now what we can do is say that this is equivalent to cosine of negative 38. And this whole thing is, if I put in cosine or sine of negative 38, I would have to change this sign, because the sine of negative 38 is negative sine of 38. So if I put the negative in here for sine, then it could turn into a plus, but the cosine doesn't switch. We can look back at the rules here. Cosine of negative theta is just cosine of theta, whereas sine of negative theta gives us a negative sine of theta. So now that we have it here, we can say this is 1/5 cosine I sine of negative 38. So let's take this, bring it up to the top. So if I said this is equal to 1/5 cosine I sine of negative 38, hopefully you see that, oh, I shouldn't say equals. I should say goes to, because we're looking for a reciprocal. This is definitely not equal to this. Don't be mistaken, like I made the mistake. It's reciprocal. So 1 over z is equal to this. 1 over our modulus, CIS, the negative of our argument. And so this is our formula. 1 over z is equal to 1 over r CIS negative theta. All right, so let's use the rule. This would be 1/9 CIS negative 141. Once we know the rules, this isn't tough at all. I hope it's not tough at all. All right, new situation. Now we're going to divide. So we have z1, 3 CIS 24, divided by 7 CIS 57. Now division is really just multiplication. So what I can say is this is 3 CIS 24 times 1 over 7 CIS 57. Now we know 1 over 7 CIS 57 is just 1/7 CIS negative 57. We learned that on the previous problem. So now we just can multiply. So if I multiply those out, this is going to 3 times 1/7 is 3/7 CIS, and now we just have to add negative 57 with 24. So 24 plus negative 57 is negative 33. So let's think about how we can do this. So if we're taking z1 divided by z2, I'll take this modulus, the modulus of the numerator divided by the modulus of the denominator to get 3/7. To get negative 33, I take 24 minus 57. And here's the formula. R1 divided by R2, CIS, theta 1 divided by theta 2. All right, let's try it out. So to do our short way, 2 divided by 7, CIS, and then we have 47 minus 230, which is negative 183. We could put a little degree sign up there if we wanted to. All right, so now if we are looking for z to the fourth, z to the fourth, that's like saying 3 CIS 47 times 3 CIS 47 times 3 CIS 47 times 3 CIS 47, which is the same thing as saying 3 times 3 times 3 times 3, or 3 to the fourth. CIS 47 plus 47 plus 47 plus 47, or 4 times 47. So 3 to the fourth is 81. 47 times 4 is 188. So 81 CIS 188. So I think we could actually look for a pattern best in this situation. Z to the fourth is going to be our modulus to the fourth, CIS 4 times our argument. And that's de Moivre's theorem. Take the modulus to the nth power, multiply the argument by n. All right, so if we took a look at this, this would be z equals 2 to the 8th CIS 8 times 50. Now, 2 to the 8th is 256. CIS 8 times 50, I believe, is 400. Yep. So z equals 256, CIS 400. Now here is your homework for tonight. Good luck.